Hi, welcome to this first video on the membrane of structure. So the membrane structure. So we probably all know that a membrane consists of a phospholipid bilayer. We have the hydrophilic, which means water-loving, heads, and the hydrophobic tails. So this is a bilayer of the membrane. The phosphate groups look like this, so this is a phospholipid. Over here we have the hydrophilic head, and over here we have the hydrophobic tails. So this is going to attract water, and this is going to repel it. The type of shape of bilayer we get is determined by the packing perimeter. The packing perimeter is given by G. G is equal to the volume of the hydrocarbon tails divided by the critical length, which is L, times by the effective area of the head. Now, if G is less than or equal to 1 over 3, we get a sphere. If it's less than or equal to 1, we get a linear bilayer. And if it's less than or equal to a half, we get a cylinder. Now, to derive those inequalities, we're going to do it for a cylinder. We take the volume of the cylinder, which is equal to pi r squared times by L prime. L prime is the length, and r is the radius, and that must equal n times by phi, where n here is the number of phospholipids we have in the cylinder, and phi is that area of the hydrocarbon tail. The area, A, or the surface area of the cylinder, is given by 2 pi r L prime, which must equal the effective area of the hydrocarbon head, of the phospholipid head, times by the number of phospholipids. We're going to imply this condition, which I'm going to call the no-hole condition. And for this to occur, R must be less than L, where L is that critical length of the hydrocarbon tail. Now, if we write R in terms of this here and this here, so we're basically dividing this by this and then times by 2, we get this inequality, and rearranging that we get that G is less than or equal to 1 over 2.